Welcome to the PrepNet, presented every Sunday at 6 p.m. Eastern Time on Talk2Me's Channel 14. Come join us to discuss everything about prepping and hear what others have done. All About Electricity, Part 13, Lithium Iron Phosphate Batteries, Part 7. We will continue discussing the use of lithium iron phosphate cells for your battery bank, and will cover how I have set up my BMS and why. For those who have heard prior nets or watched our expanded presentations on YouTube, some information here will be repeats. This is necessary for a better understanding of tonight's topic. Those who have missed any of the nets on All About Electricity should watch our expanded presentations on our YouTube channel. Okay, first, you want to get a BMS that is designed for LFP batteries. Using a BMS designed for a different lithium chemistry will damage your battery. When you install your LFP BMS, it will automatically be configured to charge your battery to a maximum battery voltage equal to a maximum cell voltage of 3.65 volts and allow the battery voltage to drop to an equivalent of a cell discharge voltage of 2.50 volts. Doing this, you will get the maximum capacity out of that battery, but you will only get the battery's stated 2,000 to 4,000 cycles. If you purchase pre-built LFP batteries that have a built-in BMS and you are not able to change charge and discharge settings, just be aware that you will likely only get the stated cycles out of the battery. This is fine if you think the 2,000 to 4,000 cycles will meet your needs. However, I want to get 7,000 to 10,000 cycles out of my batteries so my system lasts for years without needing to replace them. Before we continue, a note on charge-discharge cycles. The stated number of cycles that the manufacturer quotes is the number of cycles you will get, with no less than 80% of the battery's capacity. This doesn't mean that when the battery reaches its maximum number of cycles, that they fail. What will happen is that the battery's capacity may drop below the 80% mark, but it will still provide electric power, albeit not as much as when new. I just didn't want you to think that once a battery reaches its maximum cycles, you now have to immediately replace it. This is also a reason to have a battery bank capacity much larger than you need, as when your batteries reach their cycle life, you will still be able to run your electric equipment. So, I have a different configuration to get more cycles out of them, so let's get to it. We already covered connecting your phone to each of your BMSs via Bluetooth or Wi-Fi. The capacity configuration section. By entering the capacity of your battery here, the BMS will be able to roughly calculate the amp hours remaining in your battery. In this example, you can see the estimated amount of amp hours left in this battery is 225.8 amp hours. The total cycle capacity would usually be set to what the total battery capacity is. However, for me, this would require that the battery be drained down to 100% state of discharge to count as a single charge-discharge cycle. I don't want this. Since my maximum and minimum charge and discharge settings are different, I have my total cycle capacity set to half the capacity of the battery, which will give me a more accurate cycle count for my settings. So, my total battery capacity is 280 amp hours, but my total cycle capacity is 140 amp hours. Setting the cell full and cell minimum voltages tells the BMS when the battery is at 100% or 0% state of charge. I have my cell full set to 3.5 volts and the cell minimum set to 3.05 volts, not 3.65 and 2.5 volts respectively. The 80 to 20% entries are other voltages the BMS will use to determine your battery's state of charge. Set these as you like, but with an LFP battery, these voltages are not very accurate. The protection configuration section. This section allows you to set when battery protections are triggered. I have left the charge over and under temp, the discharge over and under temp, and the charge and discharge over current to the BMS's default. You can change these to fit your situation. The four important protections for me are the battery over and under voltages and the cell over and under voltages. Normally, the battery overvoltage for a 24-volt system would be 29.2 volts, which means that each of the 8 cells would be at 3.65 volts if all cells were the same, and would be the max voltage of an LFP cell. Too much chance of a cell overcharge here. I have my battery overvoltage set to 27.5 volts, or 3.44 volts per cell, well under the 3.65 volt max. So now if the battery voltage gets to 27.5 volts, the BMS will stop the charging of that battery to prevent overcharging the battery and any cells until the voltage drops to below 27.1 volts. For added overcharging protection, I have set the cell overvoltage down to 3.5 volts. If any cell in the battery gets to 3.5 volts, charging for that battery will stop until that cell's voltage drops below 3.4 volts, again, protecting the battery and that cell from overcharging. This is important, as even if your battery cells are balanced to within 50 to 100 millivolts of each other, you could still overcharge a cell if this protection were not there. The other two protections, battery and cell under voltage, will protect the battery and individual cells from over-discharging. If the battery's voltage gets below 24.5 volts, which would equal 3.06 volts per cell, the discharging of the battery is cut off until the battery charges to 24.9 volts. Again, for additional protection, if any cell in the battery gets to 3 volts, which would be a total battery voltage of 24 volts, the discharging from that battery would stop until that cell is charged to 3.05 volts. I only use up to 60% of the capacity of my batteries to put less stress on them and increase the number of cycles I can get from them. I also have more battery capacity than I need for daily use in case I have multiple cloudy days and cannot replace what I took out of the batteries in a day. The balancer section. This is where you set the conditions under which the passive balancing function of your BMS will turn on. I have the start voltage set to 3.335 volts and the delta to balance set to 7 millivolts. This means that if any cell in that battery charges past 3.335 volts, and the difference between the lowest and highest cells is greater than 7 millivolts, the balancing function is turned on until the difference is less than 7 millivolts. Finally, the event count section can be useful to let you know when protections have been triggered and gives you a quick indication of the battery's health. I look at the BMS over and under voltage times and the single cell over and under voltage times. If the BMS over voltage times are high, I might stop the charging of my system for a while, as I did during a long sunny period in the summer. I wasn't using the power put into the batteries from the solar array, and the BMS over voltage protections were turning the charging of most of my 9 batteries off. Or I could have increased the electric equipment I ran to drain more from the batteries. If the BMS under voltage times are high, I will check that battery's cells, and if okay, I will reduce the amount of equipment I run and or use additional charging equipment. High single cell over or under voltage times can point to a problem with that one battery. The rest of the timers must be 0. If not, you need to troubleshoot those problems. Remember that you need a BMS for each battery. In my case, I have 9 batteries, so I have 9 BMSs to monitor. Next week, we'll continue our All About Electricity series and discuss charge controllers and solar panels. If you have any questions about what we have discussed here tonight, please send your question to prepnetch14@gmail.com and enter question in the subject line.